Hello students, welcome to the e-learning platform presented by Mechanical Engineering Department of Dr. Bapuji Saroke Institute of Engineering and Technology, Kolhapur. The learning objectives for today's session are: number one, study of McPherson strut type and wishbone type suspension system. These two types are the main type of independent suspension system which we are going to study in today's session. Second, study of air suspension system. Air suspension system is basically used for our trailers or vehicle carrying heavy loads. Or we are going to study the air suspension system in today's session. And third, study of shock absorber. The different type of shock absorber will be studied in today's session. Starting with first McPherson strut type suspension system. The figure below shows the McPherson strut type suspension system. McPherson, an, an engineer, introduced a single wishbone with telescopic strut type independent suspension system. This consists of telescopic strut type shock absorber, single arm and a diagonal stay. The upper end of the strut is fixed to underside of the cross member of body through flexible mounting, and the lower part of the strut is fixed at bottom by a joint to the lower wishbone arm. The lower part of the vehicle or the lower part of the strut also carries the stub axle on which the wheel is mounted. The rotary motion of steering wheel is transmitted to the lower part of the strut, and it turns the whole unit. A helical compressive spring as shown is provided it surrounded around provided with shock absorber surrounded at the upper part of strut, which take care of road roughness, air shocks, vibration by absorbing the shock and protect the vehicle from straight is to be transmitted from the body. The application of McPherson strut type system are nowadays vehicles as Maruti Zen, Maruti 800, Maruti Swift, Alto. All the vehicle or passenger vehicles use this type of suspension system. These are easy, simple in construction, keep the vehicle camber constant. Maintenance is very low and very easy, and light moving part. They have lighter moving part and helps the wheel to follow the road irregularities. These also increase the tire wear. The quality of ride depend upon the shock absorber provided, and it cannot withstand the heavy loads. The second is wishbone type suspension system. The wishbone type suspension system, as shown in figure, consists of two wishbone arms pivoted to the frame. The upper wishbone arm is shorter in length than the lower wishbone arm. This helps to keep the wheel track constant, so to avoid the tire scrub and reduce the tire wear. A small change in camber does occur with this arrangement. The wishbone type independent suspension system is also most popular type. The coil spring is located between the lower wishbone arm and the upper side of the cross member. The weight of the vehicle is transmitted from body and the cross member to coil spring, through which it goes to the lower wishbone member. A shock absorber is placed or damper is placed inside the coil spring and is attached to cross member and to lower wishbone member. Because of V shape of arm, the wishbone do not only position the wheel and transmit the vehicle load to spring, but also resist acceleration, braking and side force. When vehicle come across a bump and wheel is tended to move up, the lower and upper arm moves up and the coil spring is compressed. So shock absorber oblique damper damps the vibration, set up in the coil spring due to irregularities. This type uh, of suspension system, the wheel track is constant, avoids the tire scrub, reduces tire wear. Right and left side suspension of vehicle is independent, so vehicle is stable on uneven surface or on the pothole or digs. Because of V shape of an arm, the wishbone not only position the wheel and transmit vehicle load to spring but also resist the acceleration, braking and side force. It requires less space as compared to MacPherson and ground clearance and better vehicle stability. Low spring rate and steering geometry is not altered with spring deflection. The difference between rigid axle and independent suspension system, that is rigid axle suspension system and independent suspension system, is shown in figure. First, in a rigid axle suspension, the spring is attached to the rigid beam axle. In independent suspension, there is no rigid axle beam. For rigid axle suspension, when wheels move or deflect vertically, having reaction on other wheel or axle, and wheel no longer remains vertical. And in independent, each wheel move vertically without any reaction or other wheel. Rigid axle is used for heavy vehicles like truck, whereas independent suspension is used for light vehicles like car at front. For rigid axle suspension, and more tire scrub reduces tire life. Independent suspension, less tire scrub increases tire life. Rigid axle suspension, steering geometry changes is steering geometry does not change in case of independent suspension system. In rigid axle suspension system are provided with slight higher spring rate, whereas independent suspension system provides softer suspension due to low spring rate. In rigid axle suspension, the wheels may wobble, whereas in independent suspension, no chance of wheel wobbling. In a rigid axle suspension, road adhesion is less, whereas in independent suspension, the road adhesion is more. So these are the differences between the rigid axle and independent suspension system. Next is air suspension spring. A volume of air enclosed either in a cylinder fitted with piston or a flexible blow can be used as a spring. Under static load, the air is compressed to a predetermined pressure and subsequently motion of piston either increases and decreases the pressure and consequently increases and decreases the force acting on piston. Air springs are fairly widely employed on vehicle whose laden and unladen weights differ greatly. It maintains constant road height from road surface. Stiffness of the system increases with increase in deflection and improves the standard of ride of comfort and reduces the noise. Basically, there are two types of air suspension spring. The first one is below type air spring. The below type air spring, as shown in figure, the spring consists of rubber or flexible below which is generally circular in cross section. The below has two convolutions for proper functioning. The constructional details are seen in the figure. The type of spring is good replacement of an coil spring. And the second type is piston type air spring as shown in figure. This type spring consists of a metal container in a form of inverted drum. This drum is fixed to frame and the sliding piston is attached to the lower wishbone. For making the system leak proof, a seal is provided by flexible diaphragm. The diaphragm is secured at its outer circumference to lip of the drum and its center to the piston as shown in the figure. So these are type of air suspension spring. Air suspension system. Air suspension system, nowadays also known as pneumatic suspension system, are employed in some tourist vehicle to improve the riding comfort of an passenger. They are mainly employed in a heavy vehicles. Line diagram of air suspension system shown in figure. As shown in figure, it consists of four airbags. The elastic element consists of housing, diaphragm with suitable air inlet and piston group. The housing is linked with the frame. The housing contains the piston group which is linked with unsprung mass. The housing and piston group are connected by metallic diaphragm for better sealing mm, and to reduce friction between each member. Each airbag is filled with compressed air. The component of air suspension system are the air filter, compressor, air reservoir, relief valve, pressure regulator, solenoid valve, leveling valve, and check valve. An air compressor is mounted on vehicle frame, supply high pressure air to the air reservoir. The compressor sucks the air from atmosphere through air filter. The pressure in the reservoir is maintained to about 20 kg per centimeter square. The compressed air in the air bag support the weight of vehicle. Whenever the vehicle come across the bump of road surface, the air in the bag gets compressed and absorbs the shock. Air is admitted into four airbags through two circuits. In one circuit, pressure reduced to 12 kg per centimeter square by pressure regulator. The pressure is kept in airbag through leveling valve. If pressure in one of the bag is low, the leveling arm moves and air is admitted into low pressure airbag through inlet valve. The outer circuit has an air pressure of 20 kg per centimeter square. This circuit pressure is used for loading in additional loading of vehicle. This can be achieved by a special regulator which keeps same distance between wheel and frame under various load. This circuit maintains vehicle level constant in loaded or unloaded condition. And for this situation, the air at 20 kg per centimeter square pressure is admitted into leveling valve through solenoid valve. Also, the air is quickly released by leveling valve whenever the load is decreased from the corresponding air bag. This lowers the air bag and hence the vehicle is back to proper level. The advantages of air suspension system: constant frequency of vibration can be achieved, high smooth run can be achieved, would provide constant body height under all static load taken by elastic element, avoid change in headlamp alignment due to varying load, and longer service life. The disadvantage is it is complicated in design, more system is required, cost is more, risk of breakdown causes the complete breakdown of an vehicle and greater maintenance required. Next point is telescopic shock absorber. For providing comfortable ride to passenger and driver as well as to reduce the additional stress to vehicle frame, it is necessary to provide proper device in suspension for damping out the effect of fluid irregularities. A vehicle must be roll or bounce or sway during turning and good road conditions. The shock absorber or a damper is a device which absorbs shock energy by damping and dissipate into heat. So it serves to control the amplitude and frequency of bouncing. It cannot support weight and has zero resilience. That is, damper is used to control the amplitude and frequency of bouncing. That is to control the bouncing movement of an vehicle. There are many types of shock absorber operating on friction, compressed air, hydraulic. The hydraulic shock absorber is now the most common type used at a present. The hydraulic shock absorber contains fluid that forces through restricting orifice as the shock absorber is operated by spring pressure. The principle of shock absorber is when a fluid moves through resisting or small orifice, it develops resistance to the movement of fluid through restricting orifice by absorbing shock energy of damping and control amplitude and frequency of bouncing and dissipate into heat. The telescopic shock absorber, as shown in figure, consists of a cylinder to which the head is welded. The head is screwed in the top end of the outer tube. To the bottom end of the outer tube is welded with a pressed steel cap or a eye or ring. This eye is connected to wheel action. The piston slides inside the cylinder. The piston is secured to piston rod and which at its upper end has an eye welded to it. With this eye, the piston rod is attached to frame of vehicle. The outside part of piston rod is protected by dust shield cover which is welded to fixing eye. A gland prevents the leakage of oil from where the piston rod passes through the head. The gland consists of piston rod, oil seal gasket, seal retainer, oil seal spring, and oil seal screw. Any fluid scraped up by the gland packing passes down a drain hole to reservoir space between cylinder and outer tube. The piston has two concentric rings of holes drilled to it. The outer ring of hole is covered at top by a disc wall which is held by star, hence disc spring. Both ends of cylinder are completely filled by a mixture of 60% transformer oil and 40% turbine oil, and the space between the tube and cylinder. When the vehicle comes across the bump, the bottom eye moves upward, then the fluid between the piston must be displaced to the top side of the piston. The fluid now passes through the outer ring of the hole in piston, lifting the top disc against the disc spring, but the volume above the piston is less due to piston rod. As such, fluid from bottom of piston will also get displaced through inner ring of hole in footwall and enter the reservoir space between the cylinder and the outer tube. So the fluid level in the reservoir space will rise. The pressure set up in the system will depend upon the size of passage opened by wall in piston and footwall. This will depend upon the square of speed at which the cylinder moves upward. When cylinder moves upward, the fluid will be displaced from upper end of the cylinder to lower end through inner ring hole in piston by opening lower disc wall against coil spring. Because of volume of piston rod that leaves cylinder, the fluid will be drawn into lower end of cylinder from the reservoir space through outer ring of hole in footwall. This passing of fluid through opening provide damping. That is, the passing of fluid through the opening provide the damping effect in a telescopic shock absorber. Next are the gas-filled shock absorber. Gas-filled shock absorber work on the same principle as conventional hydraulic shock absorber but have a gas cushion that be compressed, therefore creating space for compressed oil. The gas-filled shock up can be easily differentiated by canister which holds the nitrogen gas inside it and attached to the conventional spring-loaded shock absorber. The canister is the device connected to the shock absorber filled with nitrogen gas, which acts as reservoir for both oil and nitrogen gas. The role of nitrogen gas is to keep damping oil pressurized so that gas molecule present in the oil remain bonded with oil molecules and not get loosened to form bubble, foam, and hence prevent cavitation. There are usually two types of gas-filled shock absorber as shown in figure. Single cylinder or monotube shock absorber or twin tube shock absorber. In monotube shock absorber, the shock components are contained within one tube. As shown in figure, monotube system contains a shell case which works with the cylinder. Within that cylinder, you will find a piston wall, oil, and a gas. The construction of monotube does also include some differences compared to twin tube design. A monotube design utilizes free piston which separates the oil chamber from gas chamber within the shell case. Air is not able to penetrate the oil or gas, and since they are separated completely, as temperature increases, oil is able to release heat with less effort. It has zero restriction on installation angle and less chances of cavitation. It has more expensive and high pressure gas creates higher amount of stress on seal, which can cause more friction. In a twin tube shock absorber, there are two cylinders. In one cylinder is placed inside shell case, and second cylinder contains piston and valve which moves up and down within second cylinder, known as inner cylinder. With a twin tube design, there is no piston or barrier between oil chamber and gas chamber. This unit advantage of this is, unlike the inverted design, friction can be stopped. External damage to shell case does not affect shock absorber. Low gas pressure reduces stress on seal and also keeps the friction to minimum. The only disadvantage of this is the oil capacity is reduced and low pressure and are generally very soft. So this is it for today's session. Today's session we have completed the remaining part of an suspension system. Thank you.